Let's now see how we can consume a REST service from a Xamarin Forms application. To do that, we'll be visiting this public repository that belongs to Todmoto, which contains a list of different REST services that we can use for testing or creating applications. Notice that we have an index at the bottom outlining different categories for each of the REST services. So, we have categories for example, animals, anime-related topics, books, business, calendars, and so forth. Each of those categories is found in the section below. In a table, we can see the name of the API, its description, whether an authorization is required to use the service, if the service supports HTTPS, if it supports CORS, and the respective link. From here, you can choose a REST service if you want to do further testing, or if you need specific functionality for your applications. In our case, we'll search for a section related to weather, and we have different APIs here that allow us to create weather-based applications. One of the APIs that I found most interesting is this one from Dark Sky. Let's click on the link to see what this page contains. We can see it's an API called Dark Sky. We'll click on the button that says Test for Free. It asks for an email address. You can provide your own address, or in my case, I will generate a temporary email. After copying the email, I paste it into the address field, input a password, and click on Register. Here it indicates that a confirmation email was sent to me. I'm going to verify that this is true. Indeed, we have the email here. I'm going to copy this link. I paste it into a new tab and see that it tells me or indicates that the activation was successful. Let's click on the link that says Login. I'm going to enter the email that I copied earlier. I enter my password. Perfect, we're in. This page we've been redirected to provides us with our secret key. We need to copy this key to use it later. Here it indicates that we currently have a trial plan. We also have here a sample API call. We can try it by clicking the link. We see this call is returning a response with different weather information. If we want to know more about this API, we can open the documentation, which is highly recommended. We see that we have here an overview. We also see a section where we have pricing attribution. We see what type of requests we can make to this service. We see that the link which we can make a request on is provided by this URL, followed by the key that was given to us earlier from the page we visited, and subsequently a latitude and longitude. We have here an example of a request. We have some request parameters and more information that can be useful later if we want to make more complex request configurations to this REST service. So now that we've learned about this service, let's go to Visual Studio. Inside Visual Studio, I'm going to start a new project. As we've done before, we select the cross-platform option. We choose the mobile app Xamarin Forms template. I'm going to name this application Cool Weather. I click on the OK button. I select a blank template, all three platforms, a net standard code sharing strategy, and click OK. OK, now that the project is created, I'm going to open the Solution Explorer. The first thing I'm going to do is create a folder or folders related to the MVM pattern. So I create a new folder named Models. I'm also going to create a new folder to store our ViewModels and one last folder to hold our views. I am going to move this mainpage.xml file to the views folder, confirming that yes, I want to move this file. We are ready to continue. Let's get back to examining our REST service. For a more specific test, I'll open Google Maps in a new tab. Once on the page, we can select a specific place. For example, Mexico City. We can see that the coordinates of the particular location keep updating at the top. So, for instance, I can copy these coordinates related to latitude and longitude, copying first the one before the negative sign. And this latter parameter, which starts with a negative, that's in the case of Mexico City, and stops before the comma. I'm going to go back to my page where I carried out the first test, and what I will proceed to do is paste, instead of these coordinates, the coordinates which I have just copied. Okay, now we can see that it is returning a specific response related to the weather in Mexico City. Now that we have this information, we can return to Visual Studio and see how we can convert this entire file, which is in JSON format, into C# classes. Then, before I leave, I'm going to select this whole file, the entire content, which you can do with Ctrl+A, copy this content, go to Visual Studio, and inside the folder called Models, I'm going to create a new class which will be named Weather Data. Now that I've created my class, I'm going to remove this one, because what we will do is use a special feature of Visual Studio, which can be found in the Edit menu. The option is located in this section that says Paste Special, and it reads Paste JSON as classes. Click on this option and see how automatically, as if by magic, Visual Studio extracts all the information from the JSON file and correctly translates it into C# classes. So we can see how we are getting data like latitude, longitude, time zone, and other information. It's quite a lot of information that we are obtaining. We will carry out the renaming of this class that was created named root object, and we will name it after our file, weather data. Okay, the next thing we are going to do is close all the tabs, and within the folder named ViewModels, what I will proceed to do is create a new class which will be our view model, in this case main page, which is the name of our graphical interface file, followed by the word ViewModel. Okay, we have our class ready here. I'm going to make it public. Afterwards, I'm going to define a new instance or a property of the type weather data. We need to import the corresponding namespace. We'll name this property data. We'll set up its respective get and set to have access from our XML code through bindings. Next, I'll proceed to define a command. I'm not yet sure which control will be in charge of this command, but I'll define it as an I command. We need to import the system.windows.input namespace, and we'll name this command search command. We'll define its get and set. Subsequently, I'll proceed to create a constructor, which will initialize the search command. In this case, we'll set search command equal to a new command. We need to import the Xamarin Forms namespace, which has already been imported. We'll indicate that we want to execute an asynchronous task, which I'm yet to define. Within this function, what I'm going to do is call, through an await, a method named getData, which will take a URL as input. This method is not yet defined, that's why it is highlighted in red here. The purpose of this method is to allow us to consult our REST service and populate the data property with the corresponding values to perform data binding. So, outside this main page view model constructor, we will declare a public method that will run asynchronously, return a task, and we will need to import the system.threading.task namespace. This method is referred to as what we have defined above as getData. It is clear that we will be sending a URL, so we will indicate that we want a string type parameter named URL. Given that we are in this method, we somehow need to be able to communicate with our REST service that is online. As part of NetStandard 2.0, we now have available a class simply named HTTP client. Before, we had to install a NuGet package, but since we are using NetStandard, we have this class readily available. This is why I will declare a variable called client and assign it to new HTTP client. Notice that we have it available at system.net.http. We then use this namespace defined here. Once we have created this client variable, we will indicate that the client.base address will be equal to a new URI, passing the URL as a parameter. This instance creation of URI is necessary because this is the data type required by the base address of our HTTP client. Having defined this, we then declare a variable named response, which will be equal to the asynchronous call of client.getAsync. Here, we will specify that we want to consult a site located at client.baseAddress. Subsequently, we ensure a successful call through response.ensureSuccess status code. This will throw an exception in the event of any error, and once we are sure of a satisfactory response, we declare a variable called JSON_result, which is equal to await response.content. Then, we execute a method called readAstringAsync. This is because, if you recall, when we called the REST service, it essentially returned a text file to us. So, this is why we are indicating that we want to read this information coming in a string format. After we have read the content of this string or JSON file, we will state that we want to declare a variable called result. Somehow, we need to convert the file we are currently reading, which is in string format, into a live instance or object of the data type defined as part of our model. This is so we can match the properties we are reading as part of the JSON file to each of our classes and properties. In other words, we will assign each of the values and likewise each of the instances that are part of our REST service response. To perform this task, we go to our shared project, click on Manage Nugget Package, select the Search tab, select this package called newtonsoft.json and install it. Once installed, we return to the main page ViewModel file. As part of the assignment to the result variable, we indicate that we want to use the JSON_convert class, which is found in the newtonsoft.json namespace. We import this, there it is. This class contains a method called deserializeObject, which takes a generic as a parameter. This deserializeObject method will allow us to perform the task I mentioned earlier. So, this method needs to know the data type for the conversion. In this case, the data type we are interested in converting is the weather data class. Therefore, we set it as a part of the generic and state that the string we wish to deserialize is in JSON result. If you can see, this JSON result variable is actually a string, and basically what we do is convert this string into a live object of the weather data type. Finally, we'll specify that our property called data, which we have defined at the top here, will be equivalent to result. And with this, we would have the information in this property called data. Now we have completed our method called getData. To provide a valid URL, I'm going to go back to the page that gave us the JSON response. I'll copy this URL and paste it into this getData method call. Okay, here we have it. We will now proceed to close this file for the time being. Let's open the file named mainpage.saml.cs to initialize our view model. So, after the initialize component method, I'm going to indicate that this .bindingContext equals to a new instance of mainpage view model. We need to import the corresponding namespace, which is coolweather.viewModels. Finally, to test our application, let's open the mainpage.xaml file, and I will define a very simple interface. I'll remove this label element assigned here and replace it with a search bar element where the search command property equals binding, and here we will define the command that we defined earlier called search command. If you remember, we defined this command in our view model. Here it is, it will execute the search. We also have a property called a search command parameter, which allows us to pass a parameter as part of the command. To reuse the text property of this search bar, I will write here a syntax that is called binding. I indicate that I want to bind to the text property, but I also indicate that the source or the information comes from X, meaning we will use a reference to a control, which will be this very control. To use a reference, we need to give this search bar a name. So we give it a name and indicate that this name is search. After this X reference, I place a space and write down the name, which is search. Now with this, we are passing the text of this search bar control as part of our command. Now that we have the graphical interface defined, what I am going to do is open our ViewModel again, which is the main page ViewModel file. What we are going to do is first test that the entered text is correctly received. Therefore, as part of this command's definition, we have the parameters of this lambda expression passed here. I am going to indicate that I'm going to receive a parameter which we will call the search term. You can designate any name you want. Basically, within this variable, we should have the contents of our search bar controls text property. We will place a breakpoint at the end of the command creation to check that we are successfully receiving this term, and also to validate that in the data property we have information corresponding to the REST service. We will proceed to test the application then. Okay, here we have our application running. We will then click on our search bar. We will enter a term, for example ABC. We click on the icon to conduct the search. We see that we have reached the breakpoint in Visual Studio. So we said that we are going to check a couple of things. First, that we are receiving the correct term. Okay, we see that the search term contains ABC, which is the text that was entered, and we will also check the data property. We hover over this property and we see that we have the weather information corresponding to the information received from the REST service. We see that we have some properties like latitude, longitude, which are the coordinates we entered when testing the service in the browser. We have information about the current weather, the daily weather, flags, and other information. So we see we are receiving the information satisfactorily. Let us continue then. Now that we have our ViewModel defined, what I'm going to do is open the main page.xaml file. I'm going to connect through Live Reload. You can use Gorilla Player if you feel more comfortable with it. In order to use Live Reload, I'm going to install the corresponding NuGet package. I'll initialize it from app.saml.sys, as we've seen before. Then I'm going to run the application. So here we have our label type element that we defined earlier, indicating the weather for today. Later, for a test, I'm going to put another label element, the text of which will have a binding to a property called data, part of our view model. If we look at our model, we see it contains a set of properties. The property we're going to test is this one, which is actually another class called daily. And we see that daily contains other properties such as summary, icon, and data. Let's test this summary property then, which is really a summary of the weather conditions. So for this, we access the name of the property that is part of our model, which is daily in lowercase. So we write daily, and the property we indicate we want to access is summary. And in the same way, if you notice, it's in lowercase, so we write summary and close the definition of this label element, save this information or file, then we test a service call and see that nothing is explained to us. However, we saw earlier that the service was working correctly. This problem we are encountering is because we are not notifying our interface of the changes in our models. If you recall, we previously saw how to solve this issue. So let's head to our view model. We are going to implement the iNotify property changed interface on the class. Let's implement it. Okay, here we have the event and the onPropertyChanged method we've used previously. What I'm going to do is indicate that whenever there's an update to this data property, I want to notify the graphic interface. So I'm going to convert this property into a property with a backing field, and then for this set, I'm going to indicate that I need a body for it. So once I define this value, I'm going to call onPropertyChanged. Let's retest the application. We already have the application running here. Let's conduct a new test. And we can see that this time we have the weather summary for today in our label control. Moving on, let's customize the graphic interface of this application to make it more appealing, and one common feature of weather applications is the display of images representing today's weather. If we go back to the documentation of our API, we see that if we try to search for the term image, for instance, we find nothing related to images. However, if we search icon, we find a reference to an icon, but there's no specific image URL. This service is going to provide us with a series of strings indicating the weather conditions. So, for instance, it might return clear day if it's a clear day, a rain label if we have a rainy day, and so on. This allows for a high level of customization. What I'm going to do next is paste in a set of images into my Visual Studio project, which I'll make available in the resources section of this course. Essentially, these are the images that we'll import into our Visual Studio. So I'm going to select all the images and paste them into each of our projects. So in the case of Android, I paste the images into the Drawal folder. In the iOS project, I paste the images into the Resources folder. And in the UWP project, I'll paste these images into the Race project. The next thing I'll do is go back to my main page.xaml file, and once I know I have a label, I'll place an image type element whose source equals something. But if the service only returns a weather description label, how can we know what image to select to show the user? We'll need to create a binding, and if you recall, as part of our information, we have a property called data, which contains a property called daily, and in turn, it contains a property called icon, which is the label that represents the weather conditions so we can display an image accordingly. However, if this image element requires a data source to display a URL, and this binding to icon displays a string, how can we select an image based on this? The solution is to create a value converter. Let's return to our project and create a new folder called Converters. I'm going to create a new converter that I'll name text to image converter. This is a class. We'll turn it into a public class and implement the iValueConverter interface. We need to import the Xamarin Forms namespace and implement the required methods as part of this interface. Let's code this method named convert. Let's remove the throw of this exception. We'll define a variable called weather, which will be equal to value as a string. Subsequently, we define a variable named path, which will be equal to string.empty. What we're essentially doing is, in this variable named weather, we're obtaining the value that our icon reference contains, which is the tag to display an image according to our requirements, if you remember. So what I'm going to do is use a switch statement where I'll pass the weather variable, and I'll indicate that in the instance when the tag name is clear day, path will be equal to sunny. Finally, I'll insert a break. Essentially, what I'm saying is, if you receive a clear day tag, which is specified as part of the REST service, here we have it, then I'll indicate that the path corresponds to the sunny value, which is the name of one of my images. In this case, this sunny.png image. This will enable me to display one of these images, according to each of the cases we define as part of this converter. I will proceed to define each of these cases. Okay, I've finished defining all the cases, and the last thing I'm going to do is return this path variable. With this, I have now completed my converter. Afterwards, I'm going to return to my mainpage.xaml file to use it in this image control. To do this, I'm going to define a resource dictionary as part of this content page. I will create a reference to my converters folder. So I define that this converters reference will point to the same namespace, but in the end to the converters folder. Then later on, within the resource dictionary, I can create a reference to converters. And I can use my text to image converter. It must be assigned an X key. I'm going to call it converter, for example, and I'm going to indicate that as part of this control, within my binding, I want to use this icon property. But later on, I also want to use a converter, making reference to a static resource named converter. In other words, I'm going to use my converter to convert this value into an image. Let's test to assure this is working properly. Okay, we have the application running. I'm going to perform a search. And we see that satisfyingly, it's showcasing an image according to Mexico City's current weather conditions. Now that we see that most of the application's functionality is ready, let's proceed to modify the graphic interface to improve its appearance. To carry out this task, I'm going to encase this stack layout within a grid, and to this grid I will assign in its background color property the color 2980B9. Okay, we can see that my application now has a blue background. We'll probably modify this stack layout element. I'll keep my search bar as the first element, and I'm going to add a few properties to customize this search bar a bit. So one of the properties I'll change is its background color to white. We can now see it has a white background. Likewise, I'm going to insert a placeholder indicating coordinate search. Alright, we can now see the placeholder. Next, I'm going to specify that I also require a margin on each of its sides of 15, so it sets our control with a 15 margin value, and possibly I'll encase these elements here within a frame for a card format view. So I'm specifying that I need a frame with a margin of 25. I'll also indicate that I need a background color, which value is 3498 dB. I close my frame, place the closing tag after the image element, but before the stack layout element. And because the frame element can envelop only one component, I'm going to cut these label elements along with the image, replacing them with a stack layout, and then paste the elements I previously cut inside. Okay. Now we have a better understanding. Next, I'm going to adjust this frame to span to the end, and I'll do this with its vertical options fill and expand property. I save the changes and we can see that I now have a better looking frame. Next, I'll proceed to slightly modify how the elements look. So I cut this image and position it as the first element of my stack layout. Okay, we can now see the image. Next, this second label element, I'm going to indicate that it needs to display the current temperature. I'll do this through binding data point, and looking at our data, we see that we have here, as part of the main class, a subclass called currently, which represents the current weather, and inside we have a value called temperature. So I revert and indicate that I need to input currently.temperature. I'll save this information and see that we have the data here, but I will format it to display the degree symbol. I'll do this by inserting a comma into this binding and indicating that I need a string format. I put single quotes, and within the single quotes, brackets, and within those brackets, a 0. This tells me that the temperature value will be placed here, and after these brackets, I'll place the degree symbol. I'll update it, and although the change is minor, it's still noticeable. Let's format this control a touch. Here, I'm indicating that I need the text alignment to be centered. Okay, we see that it has now changed position. Similarly, I need it to have a large font size for larger text and also a white text color to make it clearer to see. Okay, here we have it. Next, for this second label that contains the summary, I'm going to set a few properties as well, such as a margin of 0, 30, 0, 0, and a font size property, which in this case will be medium. I also need a white text color. Lastly, I want the horizontal text alignment to be centered. I'm saving the information, and we can see our application looks much better than it did before. I will now proceed to run the application, as we are going to make the final adjustments to ensure our application works satisfactorily. For this, I am going to open my main page ViewModel file, and within this getData call, I'm going to pass search term as part of this URL. To do this, I'll place a $ symbol before my quotes to make this an interpolated string. I'll copy the variable name, come to the end, and I will replace these coordinates with search term as part of my search box. Then, within the braces, I write search term, which is the variable name that will hold the information from my search box. Finally, as part of my service, even though we have plenty of options we could configure to request information from our service, we see that as part of the request parameters, there is a parameter called lang, which basically refers to the language in which you want the REST service information. So here you can add this parameter in case you need any specific information, for example in Spanish. It tells us that we need to add the value is if we want to use it. Let's perform this small modification now. So at the end, after closing the brace, we write a question mark, the parameter name, which is lang, and set the value equal to yes. Let's save these changes. Then we'll proceed to run the application once more. This time, we will run the application in full screen, and while the application is loading, we'll search for something. For example, we'll see what the current weather is like in Cairo. Let's copy the coordinates. If you're using Genymotion, you can right-click on the search box and you'll see the paste option to paste the coordinates. We proceed with the search. And we see that currently in Egypt we have a sunny day, it's 76.09 degrees Fahrenheit, and the forecast is without precipitation for the week, with temperatures reaching a high of 101 degrees Fahrenheit on Tuesday. Let's search for another place. For instance, let's check the weather in London. We copy the coordinates. We clear the information from here. Then we paste this data again. We search. We see that on this occasion an exception has occurred, indicating that there was an exception. And essentially, these errors can occur if the information is not normalized. Here, for example, we are told that the root of currently.cloudcover is not a valid integer. It is indicating here that we are trying to convert a value of 0.25 to an integer. If we return to the API documentation and seek cloud cover, the documentation informs us that it is a percentage that can range from 0 to 1. Therefore, if we modify cloud cover to a float data type, we execute the application again. We paste the coordinates of London once more. And we see that this time the information is being displayed correctly. This type of problems can arise when you work with REST services and you need to pay close attention to the documentation so you know exactly what kind of data you should expect from your REST service to correctly model your classes. So, this is how we have learned to consume a REST service and create an application based on this service.